In this video, we'll see how we can model real-world phenomena using random variables. Take a moment to think about how often you have to visit the doctor in a given year. Once, twice, more, or maybe not at all. Well, really it kind of varies from year to year. If you haven't found that out yet, I assure you, you will eventually. We can model something like this using what's called a random variable, which takes on numerical values based on some kind of random phenomenon. In this case, we might decide to model the number of times you see the doctor in a year like this, using a random variable x that takes on values between 0 and 4. For you, this might be different, so feel free to adjust as needed. Notice that this is a discrete random variable. You can't see the doctor 1.5 times per year, for example. You can see them once, or you can see them twice, but in-between values don't make sense. We'll see examples of continuous random variables later. When we have a random variable, we usually define what's called a probability distribution, where we take the outcomes and assign probabilities to each of them. In this case, we're saying there's a 10% chance that you never have to see the doctor in a year, a 30% chance that you have to see them once, and so on. Notice that just like every other example we've seen so far, all the probabilities add up to 1. That's a requirement for a probability distribution. And by the way, that means that if you don't know one of the probabilities, you could still figure it out on your own by subtracting to make everything add up to 1. We can also represent the probability distribution as a histogram to visualize how common certain values are. With a probability distribution assigned to a random variable, we can use it to answer all sorts of questions. For example, suppose we wanted to find the probability that we have to see the doctor more than once in a given year. Since x stands for how many times we see the doctor each year, that means we're just trying to find the probability that x is greater than 1. All we have to do is add up all the probabilities from the table that fit that condition. In this case, that means x could be 2 or 3 or 4. And then we have our overall probability when we add them up of 0.6. Or we could ask a more complicated question. Suppose we've already seen the doctor twice this year. What's the probability that we have to see them 4 times total? That's a conditional probability question. What's the probability that we see them 4 times, given that we've already seen them twice? In this case, the denominator would consist of all probabilities that have us visiting the doctor at least twice. Since if we've already seen them twice, then the total number of times we end up seeing them could be 2 or 3 or 4. Then the numerator contains the probability that it actually comes out to 4 times, which is what we were asking. Many of the summary statistics we talked about with datasets can also be calculated for probability distributions. For example, suppose we wanted to know how many times we can be expected to see the doctor on average in a given year. So that means we need to find a mean, also sometimes called an expected value in this case. To find the mean, all we have to do is multiply our outcomes by their respective probabilities, and then add them up. In this case, there's a 10% chance we never see the doctor, so we'd multiply 0 times 0.1. There's a 30% chance that we see them once, so we'd multiply 1 times 0.3. And so on. Multiply each pair, and then add them all up. In this case, we get a mean of 1.75. Now, for one individual year, that number doesn't make sense. You can't see the doctor 1.75 times. But in the long run, we'd average out to 1.75 times per year. This is also a great time to use Excel's built-in sum product function. And you don't even need to divide by anything this time, because that's already figured into the probabilities in your table. We can even find the variance and standard deviation of a random variable. The easiest way to find the variance can be summed up in the phrase mean of the squares minus the square of the mean. That means you do the same kind of calculation as when you find the mean, but this time you square each outcome. So instead of multiplying the probabilities by 0, 1, 2, 3, and 4, you'd multiply them by 0 squared, 1 squared, and so on, up to 4 squared. Then, after all that, you subtract the square of the mean, which we've already found to be 1.75. Again, Excel can do this for you. All you have to do is use the caret 2 to square the outcomes. And when you subtract the square of the mean, that means you need to already have calculated the mean previously. Anyway, that comes out to 0.9875 for the variance. And then, if you take a square root, you get a standard deviation of about 0.993733. That tells you about how much variation you can expect and how often you see the doctor. So all in all, according to this probability distribution, you can usually expect to see the doctor once or twice a year, give or take a visit on average.